Hey, this is Math 6, Unit 6, Lesson 16, called Two Related Quantities, Part 1. So, first of all, as we have, it says which one would you choose? And so we want to be prepared to explain your reasoning for which one you would choose. Your options are a 5-pound jug of honey for $15.35, or you can get 3 1.5 jars of honey for $13.05. So which one would you choose? Okay, now a couple things you can consider here. Again, as you're kind of talking it through your neighbors, maybe you don't want a 5-pound jug of honey. Maybe that's too much. Maybe it's better for you just simply to say, I want to spend less money, $13 rather than $15, and have 3 small containers that I don't have to all open up at one time. Maybe you're thinking to yourself, I just want a ton of honey, so I'm going to buy that one. You can have your own reasons there. The other reason you might have is what we call, if we refer back to before, to our unit price. And maybe you just want to get the best deal. You know, this is obviously cheaper overall. I mean, right now it's cheaper, but the unit price might be something different. Remember, unit price is going to be how much it costs for 1 pound. So if you took this one, for example, and we said we had 5 pounds, and we divided 15.35 by 5 pounds, well, that would tell us that we'd have 5 times 3 is 15. 5 goes into 3 0 times, and then 5 goes into 35 7 times. So the unit price here is $3.07 a pound. Okay, what's the unit price here? Now be careful, this is not going to do 1305 divided by 1.5. We actually need to combine those because I'm buying how many pounds? I'm buying 1.5 times 3, which is 4.5 pounds. So I'm going to do 4.5 here, and I'll do 13.05, move the decimal over, decimal up. 45 goes into 132 times, which is 90. That subtracts, gets us 40 there. We bring down to 5, and 45 goes into 405 9 times for 405. So the unit price for this is actually going to be $2.90 per pound. So technically, this one's a cheaper price than that one overall. It's also cheaper just to buy it like it is. So if you're looking at just saving money or having different smaller sizes jars, this would be good. If you just wanted to buy a lot of honey real quick, that would be just fine too. But the better deal certainly is the smaller one in the smaller containers, which is unusual because oftentimes the large container saves you price overall, but this one did not. But up to you. Your job is to explain your reasoning and what do you think. Let's take a look here at this painting set here, and we're going to use this problem and this graph here, or this table, to answer several questions. It says Lynn needs to mix a specific shade of orange paint for the set of school play. The color uses 3 parts yellow for every 2 parts red. So 2 red for 3 yellow. We're going to complete the table to show the different combinations of red and yellow paint that will make the shade of orange she needs. Right, so we want the combinations to stay the same proportions so that this stays the same shade of orange. So for total paint here, we just simply add up. 2 plus 3 is 5. Okay? Now you want to think about is, as we go down the column, we look and see, well, how do I get from 2 to 6? That's multiplying by 3. So 3 times 3 is going to be 9. We add it up. Oh, sorry, 9. I say 9 and write 3. 9. And then we add across this way. So 6 plus 9 is 15. Okay, that's simple enough there. We can also look at some other ones we know. We can get to here. How do you get from 3 to 18? That looks like times 6. So to go to this column, multiplying 2 times 6 is 12. 12 plus 18 is 30. Okay, so I just skipped one for now. That's okay. To go from 2 to 14, multiplying by 7. So 3 times 7 is 21. When we add 21 and 14 together, we have 35. This is going to be 2 times 8 to get to 16. So what is 3 times 8? 3 times 8 is 24. When we add that up, that becomes 40. Here's another one with a 50 by itself and 20 by itself, so I'm going to hang on to that for now. So how do I get from 3 to 42? Well, 3 times actually 14 gets you to 42, believe it or not. You could do 42 divided by 3 to get that. That's what I did. And down here, 2 times 14 is 28. 28 plus 42 is going to be 70. Okay, so now I need to come back and fill in these ones. So these are a little different because I don't know a number of red or blue, but I have the total number. Now because proportional, we're always adding 5 every time we increase the combination, right? We had 2 plus 3 is 5, and if we did 10, we would multiply it by 2. Now notice here the difference between 15 and 20 means I'm adding 5 total cups. That's the difference there, which means I'm going to be adding another one of these basic proportions here. I'm going to be adding 2 more and 3 more there. So 6 plus 2 is 8, and 9 plus 3 is 12, and 8 plus 12 is definitely 20. Okay? Now, the difference between this one is a difference of adding 10 cups. Well, 10 cups means I'm doing whatever the initial ratio here is times 2. So 2 times 2 is 4, so we're going to add 4 to this one for 20, and 3 times 2 is 6, so I add 6 to this side, and we have 30, and 20 plus 30 is 50. Alright, so that's my table there and how we get those solutions, which is something we've done before in the past. You should be familiar with that. Let's look at the next part of this question. It says Lynn notices that the number of cups of red paint is always 2/5 the total number of cups. She writes the equation R equals 2/5 T to describe the relationship, which is the independent variable and which is the dependent variable. So basically, if we look back at our kind of equation real quick, we know we had red, we had yellow, and we had our total. Okay? And we had 2, and we had 3, and we had 5. That's our basics right there. So what we're saying here is that she's saying that if we're looking at comparing the red to the T, okay, normally we made this our y equals kx, and y was our dependent variable, so the red depends on the number of this one right here, which in this case is our total. Okay, so in this relationship here, the variable by itself becomes your dependent variable. So the dependent variable in this case is the red paint is the dependent. So how much red paint you have depends on, in this case here, the total, which is going to be the total amount. So what we would say is the value of R depends on the value of T. If I change the value of T, it's going to change the value of R in this equation here. Okay, not every equation, but in this equation, the point of this equation is when I change the value of T, it changes R. So R depends on the T. The next one says, write an equation that describes the relationship between R and Y, where Y is the independent. So the independent one is the one that goes with the K value. Okay, so we're looking at R and Y. So here's R and here is Y. And we're going to make Y the independent variable. So it's like saying this. It's like saying if I make Y and R, don't worry about it, don't think X and Y, just think that's yellow. Okay, that's a 3 and that's a 2. So what do I have to do to Y in order to get to R? That's what we're thinking about here. So 3 times what value gets you to 2? Now again, we've done this before where it becomes y over x, right? If this is x and a y like that way, and that becomes 2/3. So if I multiply 3 times 2/3, the 3's cancel out and 2 equals 2. So let's write this the correct way. We would say that, and again this was our y, that's the yellow, and this was our r. We can say that r equals 2/3 of the yellow. And that's making the yellow the independent variable right there. Now the next one says let's make R the independent variable. So to do that, we remember back from one of our earlier units, we're going to make the y the dependent times a value, a constant, to get to R. And basically, we remember this before, we're going to be taking the k value and doing the reciprocal. So it's 3 over 2. Because again, if you think about if R is 2 and y is 3, 2 times what value is going to get you to 3? Well, it's 3 over 2. So the 2's cancel out and the 3 is there. All right. So that's making the R the independent, the Y the independent. This one we made the T the independent. Just depends on which numbers you're looking at there. Okay. And again, the reason this becomes the T is independent is because it's like saying 5 times what number can get you to 2. Right. That's what we're doing back up here. 5 times what number gets you to 2. Well, it's 2/5, and that's how we got there. Question 5 wants you to use the points from the table to then do a little graph there of what you came up with. Okay. So in doing that, we look back at the table, and I'm not going to flip back and forth here. I'll look at my notes just to kind of plot it out for you. So we had when the cups was 2, when the red was 2, the yellow was 3. When the cups of red was 6, the yellow was 9. Okay, we have 2, 3, 6, 9. Let's do a couple more. We have 8, it was 12, and we're there. And then we had 12, and it was at 18, which was there. Okay, and we're going to continue that all the way through. We can see how that slope looks. So this one, though, which relationship, which equation is matched, this is going to be the one where if you look at it, we're going up 3 and over 2. So that matches y equals up 3 over 2r. So the other one then, we're going to look back. If when yellow was 3, red was 2. When yellow was 9, red was 6. So we're going to go there. When yellow was 12, red was 8. And when yellow was 18, red was 12. Okay, so just a few points there. And again, not doing them all. This is 3, 2. Over here we have 18, 12, right? So what's happening here? We're going up 2 and over 3. So R equals up 2 over 3 yellow. So the value of R is going to be Y's value times 2/3. Okay? So what we're really looking at here is that we can use a table, we can use equations, we can make graphs, and we can see the relationships there between independent and dependent variables. The idea with today's lesson is showing how things are related to each other. Okay? So in the summary here it just says equations are very useful for describing sets of equivalent ratios. And they gave you an example here of an equation, right? Or a table here. We have green to red apples, 3 to 5. And you can make a table to show us that there. And we can see from the table that R is always 5/3 as large as G. Meaning that R, the value of R, is going to equal what? G times 5 over 3. And think back, this is our X, this is our Y. And this value is y over x. That's the k value. So if y is 5 and x is 3, then that's the number that goes right there. But if we wanted to go the opposite direction and go, well, how do I go from here to there? Okay, you could think about writing the whole thing over again. Probably not what you really want to do. And call that x and call that y. And that's the 5 and that's the 3. So now you have 3 over 5 becomes the value that you multiply here by in order to get there. And you can see that then worked out here with two different equations. R equals 5/3 of G, or G equals 3/5 of R. So when you change the variables around and change the constant proportionality, it changes which one's the independent and which one's the dependent variable. But both work out and both allow you to solve different problems in different ways and approach them differently. Okay, we're going to pause there, let you work on your homework. We'll come back and check it together in just a few minutes. Alright, here's a graph that shows some values for the number of cups of sugar S required to make X batches of brownies. So you can see our batches of brownies here, and to however many number of brownie batches we want, this tells us how many cups of sugar are going to be needed. So the amount of sugar we need depends on the amount the batches of brownies that we make. Complete the table so that the pair of numbers in each column represents the coordinates of a point on the graph. Okay, so when x was 1 for the x, what was the value of the sugar? Well, we're right here at about half, or we could write that as 0.5. When x was 2, the sugar was 1. X was 3, we're at 1.5. When we're at 4, the sugar is 2. and we're at 5, the sugar is 2.5. And when sugar is 3, then we're at batches of 6, the sugar is 3, and then we have 7 is at 3.5. So what does the 0.8, 4 mean in terms of the amounts of sugar and the number of batches of brownies? 8,4 is right here. Here's our 8,4. So what does that mean? It means that for 8 batches of brownies, we need 4 cups of sugar. That's what that point means. Now to write an equation for this, okay, we want to think about this being x and s. This is our dependent, so we're going to have s equal to some value times our independent, which in this case is x. So what is that value there? Well, this is going to be our x and our y, and to find that we put a value of y over x to find out what that's going to be. So let's find some whole numbers here. Here we have a y value of 1 and an x value of 2. So we're going to say s equals 1/2 x. You can also do it as a decimal, x equals 0.5x, but it makes more sense to use a fraction based upon what we see right there. Okay? So that means that whenever I take a batch of cookies, or a batch of brownies, I multiply it by half, and that's going to tell me how many cups of sugar I'm going to need. Number 2, each serving of a certain fruit snack contains 90 calories. So a serving equals 90 calories. Got it. Han wants to know how many calories he gets from the fruit snacks. Write an equation that shows the number of calories, C, in terms of the number of servings. Okay, so that means the calories he's going to have is going to be equal to 90, because that's how much there is, times each serving. So if he has 1 serving, he gets 90. If he has 2 servings, it's 2 times 90. And that tells him how many calories he's going to have. Now the next question that goes with this is kind of thinking the other way about it. Tyler needs some extra calories each day during his sports season. He wants to know how many servings he can have each day. Servings is the N, if all the extra calories come from fruit snacks. Write an equation that shows the number of servings in terms of the number of calories. So before we said that C equals 90 times N, and now we want things to be with the calorie or the servings first. So to get that by itself, we divide both sides by 90. That cancels that out. So we say that N equals calories over 90. Number 3. Oh, was that even the picture? Oh goodness, I didn't even look. So sorry. Alright, number 3. What percent, okay, Kieran shops for books during a 20% off sale. What is the original price of the book? Yeah. Well, so what percent of the original price of the book does she pay? Well, originally it was 100, and you take 20% off, which leaves you with how much? 80. So she's going to pay for 80% of the book. Complete the table to show how much she pays for books during the sale. Okay, so 80, and she's going to do 80% of something. 80% is going to be 0.80 of whatever value you're going to have. So if we do 1 times 0.80, you have 80 cents there. Now what I thought about when I did this here, you could do, again, 2 times 0.80, but you end up with 1.60. Now look at this. This is really just some math facts, so don't work too hard here. Just think about it a little bit more. Okay, this is 8 times 2 is 16, and there's our decimal. 8 times 3 is what? 24. We're talking about money, so 240, and we have a decimal there because there's 2 there. 8 times 4 is 32. We're going to do 320 because it's 80 times 4, so decimal there. 80 times 5 is 40, right? It's a decimal there. 80 times 6 is 480, decimal there. 80 times 7 is 560. 80 times 8 is 640. 80 times 9 is 720. 80 times 10 is $8 there. Okay, so Write an equation that relates to sales price to the original price. So sales price to the original price. The sales price is going to be what? It's going to be 80% of the original price P. Okay, so that's the actual solution. My teacher's guide showed it the other way. It reversed it, but it was reversing what the letters were standing for. So that's the right thing in terms of sale price. The sales price is here. Sorry. Well, that's why it's backwards. So sales price, they say is P. They change the numbers. So that's why it's different. Okay. So sales price should be S right here in the table. Okay, and original price should be P. That's what was wrong. Okay, got it. So sales price is 80% of the original price. So that's why the book had it like that. So that's good. These table values had to change a little bit there to make it work. On a graph paper, create a graph showing a relationship. So you want to make a graph like this. And you can label one out here. And you can have your original price over here. And you can have your sales price here. And you're going to draw your dots and plot the points, and it should look something along those lines. I'm just making this up here, but you can do that on your own. All right, that's it for today. Have a great day, and we'll see you next time.